All right, the next section we're going to cover deals with solving rational and radical problems. Rationals are fractions, and radicals square root. Because now we're going to get more complex type fractions, because up until now we've been pretty softballing Mickey Mouse ones. So let's just jump straight in. Let's look at fractions. Rational equations. We've actually done these already. If I gave you something like x over 3 plus 1/5 equals 2. Remember I said there are 5 steps whenever you have fractions. Fractions and an equal sign remove the fractions. That's always been the rule. Remember we did it first step, find the LCD, multiply the LCD to each term, reduce, multiply to get rid of the parentheses, and then solve. Those are always the 5 steps whenever we have fractions and equal sign. So here are fractions and equal sign. So first step, LCD. Our denominators are 3 and 5. The easiest way to find the LCD is multiply the denominators. There's your LCD. It'll come out, it'll wash out in the end if it's too high. Second, multiply. Take this 15 and multiply it to each term separately. That was step 2, because we have 3 terms here. Now reduce. 3 goes into 15 5 times. 5 goes into 15 3 times. So we have this equation right now. Multiply to get rid of the parentheses. 3 times 1 is 3. 15 times 2 is 30. And then solve for x. Subtract 3. Yeah. 5x equals 27. And divide by 5. So x is 27 over 5. So that's what we're looking at here. It's just now they're going to be not so simple with this 3 and 5s. So let's look at this. Example 1. Solve this equation. X minus 8 over 3 plus x minus 3 over 2 equals 0. LCD. 3 times 2 equals 6. So multiply 6 to each term. Reduce. 3 goes into 6 twice. 2 goes into 3, that's 6 3 times. So we have 2x minus 8 plus 3x minus 3 equals 0. multiply to remove to get rid of the parentheses, and then solve. So it's 2x positive, negative is a negative. 2 times 8 is 16. 3x positive, negative is a negative. 3 times 3 is 9. Combine like terms. 2x plus 3x is 5x. Negative 16, negative 9. They're both negative, so you add them and solve. Move the 25 over. Here's a note. If x, at this stage here, if x is negative, the coefficient of x is negative, move that one to make it positive. All right, so if you have a chance, make the x positive. So x is equal to 5. That's my solution. All right, so let's look at another example. Because it doesn't always have to be equal to 0. It can be equal to anything. Example 2. X squared over x minus 3, 9x minus 3. We'll follow the same thing. Okay, first off, here's the first step. Find which value or values of x will make the denominator equal to 0. So in this case, they're both the same. Set them equal to 0. So that is the value we cannot use. We cannot use that value because if we plug in 3 inside here, then it makes the bottom 0, makes it undefined. So whenever you have fractions, you have to first find out what before you change anything, what x values can I not use? Since I only have one denominator, x minus 3, so we multiply both sides, both terms by x minus 3. So we have x minus 3 times x squared over x minus 3 equals x minus 3 times 9 over x minus 3. X minus 3 is canceled here. X minus 3 is canceled there. So what does that show us? If we have the same denominators, then just go straight, just do the numerators, because the denominators already cancel each other out. Square root both sides. We have plus or minus on this side. Square root of 9 is 3. So we have two possibilities. X equals 3 and x equals negative 3. Well, here we learned that we cannot use 3. So we cannot use this one. So this is our only solution. Because we cannot use positive 3. Example 3. Get used to always checking your answers. Once you get an answer, plug it back into the original equation and see if it equals the same thing. So x squared. If x is negative 3 times negative 3 is positive 9. Negative 3 minus 3 is negative 6. So it works. It gives you equality. Now we have a little bit larger one. What this example shows us notice all these denominators look different. Always factor, actually I'll say all the functions. The numerator and denominator. Since nothing can be done on the top, how about the bottom? 3x plus 6, they both have a 3 in common. If I take out the 3, I divide both of these. So I have x plus 2. This is a quadratic one, which means we're going to have 2 of these. If you have an equation that looks like this, we know this is true because if we took a plus b times a minus b, it'll give us a squared. It's what we did when we did complex numbers. This is called the difference of two squares. Two squares. Because we have one number squared minus another number squared. This one is x squared. 4 is made up of 2 squared. So it's a difference of two squares. Therefore, it's a plus b, a minus b. So it's a or x plus 2, x minus 2 equals 4 over x minus 2. Now we look at this thing and see that there's only 2 real different types of denominators here. Here's an equation, x plus 2, x minus 2, and 3. So the LCD is 3, x plus 2, x minus 2. So we multiply 3x plus 2, x minus 2 to each term. Also, note we have 2 equations. We have x plus 2, set that equals 0, x minus 2, set that equals 0. So x equals negative 2, x equals positive 2. These are the x values I cannot use because it'll make the bottom 0. So now here we see x plus 2 cancels, the 3 cancels. So we have 2 times x minus 2, x plus 2, x minus 2 cancel. So we have 3 times 1, and the x minus 2 cancels. 3 x plus 2 times 4. It looks a lot easier than the original one. Multiply it out. We got 2x minus 4 plus 3. 3 times 4 is 12. So 12 times x is 12x. 12 times 2 is 24. Combine like terms. 2x minus 1 equals 12x plus 24. We have x's on both sides. Move the smaller to the larger. So subtract 2x from both sides. Negative 1 equals 10x plus 24. Subtract 24 from both sides. So it's negative 25 equals 10x. Divide by 10. So x is equal to negative 25 over 10, which can be simplified because 25 is made up of 5 times 5, and 10 is made up of 2 times 5. The 5's cancel. So my final answer is that. And since it's not one of the numbers I can't use, it's a legitimate answer. Okay, so those are rational equations, fractions. Now things change a little bit when we have radicals. Radical equations. With square roots. All right, so let's look at this. We know that if we have square root of x equals 2, to get to the x, we have to square both sides, because the square and the square root cancel. Notice, now since we're going backwards, we're squaring a square root. So the answer is what the answer is. So if x is 4, square root of 4 is 2, check. Now, what if we had an equation inside there? X plus 2 equals, say, 3. Important, remember, square roots can never be negative, because remember this, the graph of a square root is like this. We cannot have any x values that are negative. 0 is the smallest, and we cannot have any y values that equal negative. So to solve this, I isolate isolate the radical term. Notice there's nothing in front of it, nothing behind it. It's just a radical term on this side and somewhere everything else on the other side. Square both sides. So those cancel. So we have x plus 2 equals 9. And solve. Subtract 2, x equals 7. And then check your answer. CYA. Our original equation was x plus 2. So if x is 7, 7 plus 2 equals 3. So So check, it works. So this is our legitimate answer. Let's look at example 4. What if we had the square root of 3x plus 1 equals 4? Yeah. Radical on one side, number on the other side. So I square both sides. Square root and the square cancel. Equals 4 squared is 16. Solve for x now. Subtract 1. 3x equals 15. Divided by 3. X equals 5. Remember, check your answer. 3 times 5 plus 1. 15 plus 1 is 16. Square root of 16 is 4. So it works. So that's the right answer. Example 5. Okay, now we have a number in front of there. And we have an x on the other side. Again, same thing. Isolate the radical. So we subtract 5 from both sides. So we have the radical of x plus 7 equals x minus 5. Square both sides. This is one number. X minus 5 is one number. If I square that side, I have to square it as a number. So those cancel. So I have x plus 7. Now this one becomes x minus 5 times x minus 5. So with the FOIL, x times x is x squared, negative 5x, negative 5x, positive 25. Combine like terms, so it's negative 10x. Since it's a quadratic equation, we have to move everything to one side. So we subtract x, and we subtract 7 from both sides. Because it has to be equal to 0. Negative 10 minus 1 is negative 11. 25 minus 7 is 18. Now we solve this. We have x squared minus 11x plus 18 equals 0. Fortunately for us, we could factor this one out. X times x, that's x squared. The second sign's a plus, which tells me the signs are the same. They're both negative. Now, what two numbers multiplied to equal 18, when I add them, they equal 11. 9 times 2, 9 plus 2. So now take both of these and set them equal to 0. So x equals 9, x equals 2. Remember, these are our possible answers. Let's see. 9 plus 7 is 16. Square root of 16 is 4. 5 plus 4 is 9. Check. So this one's good. 2 plus 9, 2 plus 7 is 9. Is square root of 9 is 3. 5 plus 3 is 8. Does not equal 2. So this is the only answer you have. So you have to check them. Anywhere I see an X, I put a 9 first off. Anywhere I see an X, I put a 2 in the second and see what happens there. Okay, example 6. X minus 3 plus X plus 5 equals 4. Okay, looking at these right now, the domain of this one, the domain of the first one is, if I take X minus 3 equals 0, X equals 3. So 3 is the smallest I can use, or the largest. If I have anything smaller than that, if I have a 2 or a 1, so my answers have to be bigger than 3 for the first one. And for the second one, I have an X plus 5 equals 0, so X equals negative 5. So for the second one, I have to have all of my X's bigger than negative 5. So can I use a negative 4? Yes, in that one, but not in that one. So my domain is all my, if I overlap them, here's 3 and here's negative 5. The point that they overlap is here. So 3 to infinity. That's my domain for this question. We talked about that earlier in the course in chapter 2. Right. So in this method, in this process here, you still isolate one of the radicals. So let's leave the first one alone, X minus 3, and move this one to the other side. Equals 4 minus radical X plus 5. Okay, so that's our first step. Isolate one of the radicals. Then square both sides. On the right-hand side, it's one equation. So as you guess, we have to FOIL this one on the right-hand side. So left side cancels out. Now on the right-hand side, we have to work it out. Let's stop. So it's 4 minus radical X plus 5 times 4 minus radical X plus 5. Four times 4 is 16. Positive negative is a negative. 4 times radical X plus 5. Negative times positive is negative. 4 radical X plus 5. Negative and negative is a positive. Radical X plus 5 times radical X plus 5 is radical X plus 5 squared. Okay, combine like terms. Negative 4 and negative 4 makes it negative 8 of the radical X plus 5s. the square root and the square cancel, so x plus 5. I don't need a parenthesis since that's a plus. If it was a minus, I'd have to parenthesis because I have to distribute that minus sign through there. Combine like terms. 16 plus 5 is 21, plus x minus 8, x plus 5. Okay, now we can't go any further. We have to isolate this radical. So get rid of everything else. No, we can't now. That's multiplied. So we have to first subtract 21, then subtract an x. So those cancel. X minus x cancel. Negative 21 minus 3 is negative 24. Okay, if that 8 wasn't there, if we just had this, negative 24 equals that, there would be no solution because a radical, a square root can never equal negative. Square root of x can never equal a negative number. So there's no solution. But fortunately, this is negative 8 times that. I change the signs, so it's 24 equals 8, x plus 5, divide by 8. So I have square root of x plus 5. 24 divided by 8 is 3. Square both sides. X plus 5 equals 9. Subtract 5. X equals 4. And if I plug 4 back into the equations, four minus 3 is 1. 5 plus 4 is 9. Square root of 1 is 1. Square root of 4 is 3. So we have 4 equals 4. So that's a good answer. All right, so that's section 4. So just be very, very, very careful when you do those. And each step can be taken. I mean, you have to be very careful that you don't do careless sign error like I always do. Okie doke. Well, that does it for that section. Thank you, everybody. Have a great day.